Hey there, this is Ashwin Kulkarni. I welcome you all in this series about Kubernetes and Golang. In this series, we are going deep dive into the Kubernetes, its concepts, and we are going to write the hands-on code along with the Golang microservice and the concepts about Go. In the introductory session of the series, I have discussed about why I want to start this and what's the importance of Kubernetes and the Golang and all. Now let's straight away jump into the first part of the series, which is about understanding the Kubernetes. So to understand the Kubernetes, first, the very most important is its architecture. In this video, we are going to understand the different concepts of Kubernetes, its architecture. We are going to check the actual those components on the Kubernetes by writing the commands. And this video will be just an introductory about the Kubernetes. We are not going to do much about the Golang in this one. Okay, so let's straight away jump into it. So the Kubernetes architecture is by default a very robust in its nature. So at the heart of it, it is basically designed to handle the scaled application, handle the large amount of microservices deployed on top of it. The by default, the components has its own roles to play, and the overall architecture is basically dependent on mainly two components. I won't say components, but two parts. One is the master node or control plane, where all the brain of the management is available, and then there are several other nodes which communicates with the brain. Now, first of all, let's try to understand what is the node. So node is simply physical or virtual machine where Kubernetes is launched. Okay, so essentially on a particular node, you can basically run a Kubernetes and do its job. That's it. That's about the node in the simplest format. Okay. Now, the overall Kubernetes is designed in such a way to be fault tolerant. Then it is designed to scale on its own. And by the way, fun fact is, Kubernetes is totally written in Golang. So again, my favorite topic. Now, basically, since it is very fault tolerant and it is very useful to automate the deployments, it is basically very popular in the cloud environments. Okay. Now, what is the cluster? Okay, so cluster is set of the nodes. So you have different such physical or virtual machines come together, make a big circle to make it a cluster. Okay, so basically you have a node 1, node 2, and that makes a cluster. That's it. So it is normal clustering in any machine learning or anywhere. You can just think of it like it. Now let's jump straight away into the architecture. Okay, so as we discussed, it has the master node, and there are several other nodes are connected to it. Okay, so this number can be dependent on how your basically how your CPU can tolerate the resources about it. So based on that, these other nodes can be scaled. Okay, so this is node 1, this is node 2, as explained here. Now, the master node is also called as control plane. Okay, it has mainly 4 to 5 components. The first one, I'm saying 4 to 5. I have discussed the total 4 components here: 1, then 2, then 3, and 4. But overall, it has one more component which is useful in the cloud environment, where you want to basically connect to any such cloud provider such as AWS, IBM Cloud, or GCP, anywhere. That's where there is another component which comes into picture, but we are not going to talk about it in this one. So the first component is API server. Okay, so I'm going to talk about it one by one, but I'll just explain the components here. So this is the first component, API server, which is basically communicates with other node and also it is able to communicate when we run the CLI commands, or you can basically connect to these control plane with the APIs as well. So wherever you're putting the request or you're writing a CLI command, it straight away comes to the control plane. Okay. Now there is a second part, which is etcd. So Kubernetes needs to store many information about its control plane, about its node and all. Now to store this, it somehow needs some kind of data store or database, right? Now etcd is a key value pair based data store, which helps to store the data and information about the control plane and about the other nodes as well. Okay. Now, third one is the kube scheduler. So this is the brain. This is basically the brain of all whatever is happening in the control plane. Okay. So what it does is, it is responsible for the node management, then job management, and then we are going to talk about the service accounts and all. So all these resources which this control plane manages, it is responsible for that. So what I mean by node management is basically how your nodes are connected to the control plane, and then number of nodes that are spinned up, then how those are getting communicated and how the data is getting stored and all the information is getting communicated. All that stuff is maintained by scheduler, and also it basically helps Kubernetes to decide on what particular job to run on what node. So kind of, because its name suggests that it is a scheduler, right? Now coming to the node components. So there are again mainly three components. First one is the kubelet. Now if you see in this diagram, kubelet is essentially straight away connected to the control plane or master node. So of course these nodes are connected to the master node. Now somehow these needs to be communicated to transfer the information about what's happening in these nodes and what needs to be transferred, etc. Right? So kubelet is an agent that runs on each node and that makes sure that containers are up and running, and it sends this information back to the master node or control plane. Right? Now there is a kube proxy. So it is kind of a network proxy that runs on each node, and it basically it is able to run the Kubernetes service concepts, Kubernetes networking concepts, port management, etc. So we are going to deep dive into that when we are going to each component, but this is about that. And then there is a container runtime, which is fundamental component that empowers Kubernetes to run the containers. So already or we will do a separate video about what are the containers and all, but just you can say containers are small set of bubble which runs a particular amount of code or which runs a particular package. Okay, so for example, you can run a Node.js server on a particular container, or you can run a MySQL database in particular container. You can club those containers together, and basically you can write it in the Docker file to make one such project, and you can deploy it on a node. Okay, and you can deploy it in the form of pod, and that pod basically gets deployed onto a node, and that management happens via container runtime, about how these pods are getting managed, the health of the pods, and etc. Okay, so these are the main components, and simply there is a control plane, and you just need to understand this. There is a control plane, that means some master, which is basically observing its small nodes or small children of it, and it is managing them. That's it. Now these children basically request something or communicate with the master node. Master nodes does something about it and then process the information or process the request. That's it. Okay, so on top of it, this is the overall architecture of the Kubernetes. Now in the next part, we will just straight away jump into the code. I mean, we'll just write the commands to see these components actually on the Kubernetes environment. Okay, let's go. Now let's see using the command line tool about the clusters and its components in a very short way. Okay, so I have set alias for kubectl command as K. Now what is kubectl or kubectl command? So it is basically a command used to access or used to manipulate the all the resources available in the Kubernetes. We are going to deep dive into the command in later videos as well, but for now just let's skip that importance of the command. So if you see kubectl and if you want to do config and get context, okay. So what is Kubernetes context? So essentially it is a bubble where all the information about users, cluster administrator, roles, and namespaces, everything is set up. Now essentially this means that I have two clusters in my machine, and it has its own resources available in it. Now let's move on to one cluster. So kubectl config, I just want to move on to the first one. Now I have moved to a one cluster. Now I want to see the nodes of it. Okay. So if you see, I have three nodes. Out of one is the master node, right? So if you see, the roles of it is a control plane and master, right? And all other two nodes are the simple worker nodes. We haven't set anything in it right now, and we will not set anything in it in this video. Now if you want to get the resources, so if you see, if you just want to see the status, the command is deprecated, but simply you can see the status of the component as etcd is working, your scheduler is working, control manager is also working. Now there is a command to hit the liveness and readiness endpoint of the Kubernetes to get the details of all the components and the statuses about it. So if you just run this command, so essentially we are just hitting the ready endpoint of the Kubernetes. You can see all the components status as their status as okay or non-okay, whatever. So you can see etcd is there, etc readiness is there, API server is there, CRD is there, the service IP manager is there, then the authentication about it is there, then kube API server is again it is there, which is the garbage collector of it and all the related components of it. Now you can see interesting stuff is API service open API version 3 controller is also there. So this has got added newly. So with this you can see the statuses of all the components straight away into this. Okay, so that's about it for the today's video. I hope you got the basic crux about the Kubernetes architecture and how it works and what are the components and all. And these sessions will be like this, so I'll be explaining the concepts, and then we will go deeper into the coding part or the commands part, whatever is required for that concepts. So that's about it for the today's video. Thank you so much for joining in, and I'll see you in the next one. Bye.